All right, welcome back. So this is question 42 from chemistry section in IMAT 2022 past paper. So I will be explaining how to solve this question. It says, in which of the following reactions does HCl act as reducing agent? So before we go through each of these options, we must recall the basic definition about redox reaction and this term reducing agent, which is the most important. So first of all, what is redox reaction? So the basic definition about redox reaction is, first we must know the full form of this. So read, the red stands for reduction and ox stands for oxidation. Okay, so basically this redox reaction means basically it's a transfer of electrons E minus between the species. Okay, so there are certain species that either gains an electron or they donate an electron. So the species that gains electron are called reducing. They're called reduction, sorry. So species that gains electron, this process is known as reduction, and oxidation are those species that loses electron. So this is oxidation. So species that lose electron are is called oxidation, and species that gains an electron is reduction. Okay, so the most easiest mnemonics you can memorize for to recall this is oil. Wait, oil rig. Okay, so this is the most easiest mnemonic you can easily memorize. So oil stands for oxidation, losing an electron. Oxidation, losing. So the word L stands for losing electron, and rig stands for reduction that gains electrons. So the word G stands for gains. Okay, so this is basic mnemonics you can memorize to recall this basic definition of reduction and oxidation. And the most important thing you must remember that redox is just transfer of electrons between species, and species that gains electron are reduction, and species that loses electron is oxidation. Okay, so this is the basic definition you must know. And now we'll move to the certain terms that are reducing agents and oxidizing agents. So what are they? So there are two types of agents. So reducing agent. So first we're going to focus on the definition of reducing agent. So reducing agent are those agent that reduces other species, other species. So the other species gains an electron. Okay, so the agent that reduces other species but itself gets oxidized. Meaning, so in the simplest definition is that reducing agent are those that reduces other species. So this means that other species gains an electron from this reducing agent, but reducing agent itself gets oxidized, meaning it loses an electron so that the other species gains an electron from this agent. Okay, so now oxidation, oxidizing agent, sorry, oxidizing agent. Okay, so agent that oxidizes other species but itself gets reduced. Okay, so agent, so oxidizing agent are those that oxidizes other species. So that species that's being targeted by this agent loses an electron, but itself, the agent, the oxidizing agent itself gets reduced, meaning this agent gains an electron from the other species that lost an electron. So that's the definition for reducing agent and oxidizing agent. Okay, these are these are the most important key points you must recall to solve this question. Okay, so now that we've known the definition, the most important ones, now we can go through each of these options. So first of all, we'll go for option A. Okay, so it's mentioned manganese oxide plus hydrochloric acid, or you can say hydrogen chloride, gives manganese chloride plus a chlorine molecule plus water. Okay, so now before we solve this, we must know the oxidation state for each of these elements in this compound. Okay, so the main element in this compound that I'm going to focus on is manganese. Okay, so for this manganese, it's going to be plus 4. So how do I calculate that? It's easy. For this compound that I'm focusing on, manganese oxide, I'm going to consider manganese as X. And for oxygen, I simply know it's highly electronegative element. So its charge is going to be -2. Okay, so this means X plus 2 of -2 is equal to 0, because I know it's a neutral compound and its overall charge is 0. So I'll equate it to 0. Okay, so the value of X, which is the oxidation state for manganese, is going to be 4. So 2 times 2 is -4. You take that side, it becomes +4. Okay, so that's the simplest way you can find the oxidation state for specific elements you're looking for in a specific compound. But you must know that, for example, such type of common element like oxygen, chloride, these already are highly electronegative elements. So you must know easily it's going to be -2 or -1. Okay, so at least for some element in the compound, you must know its oxidation state by default. But for other element like manganese, these are like special element that has variable oxidation state. Okay, so the manganese has positive charge of +4. Okay, so its oxidation state in this compound. So in HCl, I'm going to focus on this chlorine atom. It is -1. Okay, so now over here it's going to be +2. Okay, so over here the oxidation state of chlorine atom in this compound, the chlorine molecule, is going to be 0. Okay, so now what happened is HCl here act as reducing agent. So why is that? Because it itself lost an electron. That's definition of reducing agent. Itself gets oxidized. As I said, oxidized species mean they lost an electron while they cause the other species to gain electrons. So that's reduction for other species. So the other species that got reduced is manganese, because it has its charge reduced, meaning it has gained 2 electrons, that has its charge reduced from +4 to 2 plus. And for this hydrogen chloride, it goes from -1, the oxidation state on the chlorine atom, to 0. So it has lost an electron. So therefore, HCl in this reaction acts as reducing agent. Okay, so this was pretty quick. So the correct option is option A, but I'm still going to go through each option so that we can have a clear look about what does hydrogen chloride act as in these other reactions. So, okay, the second one we have is zinc plus hydrogen chloride giving hydrogen gas and zinc chloride. Okay, so first thing first, I already know it's a neutral compound, so it's 0. Okay, and the same thing over here, I'm going to add as over here as +1 and 0, and over here it's going to be +2. Okay, so now you may think, why did I choose hydrogen over here instead of chlorine atom, and then the previous reaction I chose chlorine atom? This is because now there are different scenarios where you have to switch. Because over here I know chlorine atom over here is -1, and same it's going to be -1. Okay, but here there's other element in this compound which is hydrogen. It turns from +1 to 0 over here, and so therefore HCl in this reaction acts as oxidizing oxidizing agent. Okay, oxidizing agent, because hydrogen in this compound HCl goes from +1 to 0 in this hydrogen gas molecule. Okay, so it has gained an electron, and reason why it has lost its positive charge. So gaining more electron will have the charge lowered. Okay, it moves more towards the negative side. And for zinc, it has gone from 0 to +2, so meaning it has lost an electron. So oxidizing agent, the one that oxidizes other, that loses their electron, but itself get reduced, gains an electron. So zinc has lost an electron. Okay, so this option B is also wrong. Now option C, magnesium hydroxide reacting with hydrogen chloride, giving magnesium chloride and water. Okay, so this is clearly an acid-base reaction, and we know that most of acid-base reaction are double replacement reaction. So that's why they're not considered redox reaction. So why is that? It's simple. Okay, so over here, magnesium, I know, is going to have a charge of +2, and over here it's going to be +2. Okay, so over here the hydroxide, I'm going to ignore it. And HCl over here, I'm going to focus on this chloride, the chlorine atom, and it's -1 in this compound, and it's also going to be -1 in this compound as well. So now you can clearly see that there's no change in the charge at all. The charge overall, the oxidation state overall is same in both of these compounds. There's no change in the oxidation state. So that's why this is not redox reaction at all. So we won't focus on this reaction at all. Okay, so redox. Okay, so this is not redox. Okay, so no, option D, ammonia reacts with hydrogen chloride giving ammonium chloride. So I know over here the nitrogen, the charge over here is -3. Okay, and over here it's a -1, and same is going to be -1 over here, and also -3. So why is that? I'm going to make it simple. If you divide this NH4 plus, okay, I consider nitrogen as X plus 4, all positive charge hydrogen and water. Okay, so I'm going to take that side. Okay, 4 to that side is going to be -3, and so that's why the oxidation state remains the same. Okay, so that's why this is also not redox reaction. So Now option E, aluminium oxide reacting with hydrogen chloride giving aluminium chloride and water. So this is also an acid-base reaction because aluminium oxide can also act as an base because this is amphoteric oxide. Aluminium oxide or amphoteric oxide. Okay, so and yes, overall there's no change in oxidation state. So I'm going to write here clearly. Okay, so I'm gonna consider this as 2x plus 3 of minus 2. Oxygen, the charge on the oxygen is basically negative 2 and the compound is neutral. So I'm going to simplify and the value of x, which is oxidation state on aluminium, is going to be plus 3. So it's going to be plus 3 over here and also plus 3 over here. And it's negative 1 over here and negative 1. So this is also not a redox because there's no transfer of electron. And also there's no change in oxidation state at all. So this is how you solve this question. It's basically easy. So that's all. So okay, so thank you guys for watching my video. I hope you find it helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.